Welcome to Internet, a bunch of cables. The Internet explained. So, what if I told you that the whole idea of the cloud, this magical wireless thing you use every single day is actually a massive planet-spanning network of very real, very physical hardware. You're on a rock floating in space, surrounded by a bunch of nothing. Here at Quantum Quanta, we are here to find out what the heck is going on. Remember to subscribe, like, and share this video. Thanks. We're about to demystify the internet. And I think you'll be pretty surprised to find out what it's really made of. I know, right? Whoa. It sounds like a joke, like something you'd see in a meme. But honestly, this is the fundamental truth we have to start with. Forget data just floating around in the air. At its absolute core, the internet is just a bunch of incredible thick cables sitting at the bottom of the ocean. Okay, so that raises a pretty big question, doesn't it? How on earth does a cat video get from a server in, say, California, all the way to your phone in just a matter of seconds? Well, to get that, we need to understand the internet's physical body. We're talking about millions of miles of fiber-optic cables crisscrossing the entire planet. Huge number of them are laid deep on the ocean floor, physically connecting one continent to another. These cables are basically the superhighways, and they all connect to routers and these massive data centers that act like the cities and traffic interchanges of this global network. Okay, so we've got this gigantic planet-sized web of actual hardware. Your laptop's on it, my phone is on it, the server with your favorite website is on it. But with billions of devices all connected at once, how does anything find anything else? Seriously, think about it. How does your computer just sitting there in your living room know the exact path to take through? All those undersea cables and all those routers? To find one specific server that might be thousands of miles away? The solution, it turns out, is actually pretty elegant. Every single device that connects to the internet gets a unique identifier. It's called an IP address. You can think of it exactly like a postal address. If the internet is a map of the entire world, the IP address is the specific street, the house number, and the city for every single house on that map. It's how data knows precisely where it's supposed to be delivered. But there's a human problem here. Are you going to memorize a string of numbers like 142.250.191.78? Every time you want to search for something? No, of course not. Our brains just aren't built for that. Which is why the whole system needed a kind of address book. And that address book is the DNS, which stands for Domain Name System. Just think of it as the internet's universal contact list. So when you type something simple like google.com into your browser, the DNS instantly looks it up, finds the matching IP address, and tells your computer exactly where to go. It is the reason you don't have to memorize phone numbers for websites. So your computer's got the right address. Awesome. But how does your message, whether it's a search query or an email, how does it actually travel across all those undersea cables to get where it's going? Well, the magic behind this whole process is a protocol called TCP/IP. See, instead of trying to send one gigantic file all at once, which would be super slow and just clog everything up, your computer acts like a digital shredder. It chops your message up into thousands of tiny little pieces called packets. Each packet is like its own little postcard with the destination and the return addresses stamped right on it. Then they all just get sent out into the wild. And each one finds the fastest path it can. It's kind of like organized chaos. And when they all arrive, the receiving computer works like a puzzle master, making sure all the pieces are there and then putting them back together in the exact right order. But wait, what happens if one of those little digital postcards gets lost in the mail? It's called packet loss. And believe it or not, it happens all the time, but the system is brilliantly designed for this. The receiving computer just notices a piece is missing and asks the sender, "Hey, can you resend just that one piece?" It's this incredibly efficient self-correcting system. Okay, so we have this incredible physical network of cables and addresses and these little packets flying around. But here's the crucial point. The one thing that most people miss. All of that infrastructure that's not actually the web. The internet and the web are two completely different things. Let's think of it this way. The internet is the physical infrastructure. It's all the roads and the highways and the shipping lanes of the world. The World Wide Web, on the other hand, is what travels on those roads. It's the cars, the shops, the houses, all the information and services that you actually see and interact with. The internet is the hardware. The web is the software. So all the things you actually do online, visiting websites, streaming your favorite shows, sending emails, and yes, looking at endless cat pictures or getting rickrolled. That's the web. It's all the software and the content that runs on top of the internet's physical hardware. So when you really stop and think about it, from a message being chopped into thousands of tiny digital postcards, each one addressed and sent across a global network of undersea cables and then perfectly put back together on the other side. Isn't that just mind-blowing that it all happens in the blink of an eye? The next time you watch a video, just take a second to remember the incredible physical journey it took to get to your screen. Remember to subscribe, like, and share this video. Thanks.